Welcome to the fifth video of SDL game project. Since this is the final video, I will cover every aspect of the progress very briefly. I will start by a short demo. I've started the game and I can see the cube is being shuffled by two moves randomly. Now I'm gonna perform a move. So there's two ways of performing a move. I can either press keys, so for example I can press T for top face and it rotates the top face clockwise. There's also another way, so I can perform dragging, and simply that face rotates in the given direction. So for example, if I want to rotate it anti-clockwise, I can just rotate it in the other direction. So for a move to be defined geometrically, the cube requires to have a front face to the user. So for example, this is the front face, and now I can perform any move as I like. I've made the rendering process slow so you can easily observe the animation. So what happens if the cube is not facing anywhere? So it works in few obvious cases. So like as you can see, the down faces and top faces are defined geometrically, and so for example in such cases as these. And that's all. And there's also load and save game options. So the reason I've not included them in this start menu screen is that to give the user the feasibility of going to the previous moves. So like if I'm saving the game now and for some reason I got confused in my moves and I want to return to the previous situation, so I can easily load the game and the cube returns in that previous state. So there's a load txt file there. If I can show you, here it is. It is saving the geometrical orientation of the entire surface, and on loading game it reads the same load file. So I can choose to pause the game by clicking this button over here. I can very well return to the game, and if I wish to quit, I can press yes. What happens if I quit now, and I wish to load the previous progress? So I can very well do that, and there it is. So there's also another feature added in, a more difficulty mode. I'll demonstrate that as well. So you can see numbers on the faces, and these types of cube having patterns on the faces are relatively much more difficult to solve. So for example, now the red faces are also have to be like perfectly oriented in like numerical order. So for example, if the reds are like oriented on the same face, but still the one is not on the place where it is supposed to be, so the cube is not detected to be solved and the game does not end. So I've built the game again and making sure that it shuffles only once after starting the game, so it will be relatively easier for me to solve and show you how the game proceeds after the cube is solved. So after I have solved the cube, so as you can see it only made only one shuffle. I'm gonna solve it, and there you go. Now I cannot move any further moves. I can just rotate its orientation, and I can only return to the menu, and that's all for the game ending part. Hi, in this part I'm gonna demonstrate the backend programming of the design patterns and the polymorphism implementation. So as you can see in this user move class, I've implemented the build factory method. So as you can see, this I move, which is a pointer to the parent class to these spin classes, is being assigned at runtime depending on the user input, and then thereby performs the rotation depending on the user input. Secondly, there's singleton factory method in the face class. As you can see, a static singleton pointer has been created of the same class, and this is being initialized and defined in this .cpp file. There's also several virtual functions you can find in, for example, this matrix class. So you can see these virtual functions. It is a abstract class, and there's also other abstract classes. So this rubric class is also abstract. As you can see, there's a few virtual functions.
Hello guys, my name is Sabi and I will be taking over the end of the video. In the first 7 minutes, my group partner Shrams explained how all these technical and thematic requirements which are currently present on the screen were met in our game. He showed how the classes were polymorphism, including the operator overloading part, were implemented. In the starting menu with buttons were displayed, the input-output file mainly named as the load.txt to save and load our progress, including a sort of pause screen at the end. So our instructor asked us to integrate sound into our code. So I will be showing you that we were successfully able to integrate sound on a loop in our video. So we use it using downloading the SGL mixer library and try to integrate and starting sound in our game. So far a single track has been integrated due to limited availability of time, but this shows that we can run different sounds on different soundtracks on different key presses, and so far all of our requirements are met, including different design patterns. So I will be opening my code now and building it, and then I will be executing it. Okay, so even though I've built up the code, I'm just gonna build up once again. Now since the code has been successfully built, I'm just gonna execute it ./a.exe. Okay, so now you can see as soon as I run it, there's a start of sound, and I can increase the volume so that the sound will increase actually. I'm going to start the game. You can see the sound is on loop, and at a time, as soon as the sound track ends, it will restart again. So as you can see out here, the rendering speed has been set back to normal, so you can see, and even though I'm just gonna click and drag my mouse, so it's gonna rotate, see. So I can also save my game at a point, so I'm saving and then I'm going back. I'll just click the save button and then I'm going back. So return to there's a game pause video, so if I just press yes, I'm on the main screen again, and I'm just gonna click on start game again, and I'm just gonna load my game again. So you can see, even though the cube has been rotated a bit, the axis has been rotated, but all of the combinations are the same, as you can see right out here. You can just see rotate any part of it. Okay. Thank you guys. this concludes our final game. Thank you.